Hello guys, in this video we are going to be looking at problems on concentrations of solution and its unit. In the previous video we have talked about the types of units that we have for solutions. Here we want to solve some questions that are related to this topic. So for you to be able to follow up and understand these questions, I will recommend you check the previous video that is talking about consideration of solution and its unit, so that you can follow up very well. Thank you. So let's get started with the first question. You can see on the screen we have the first question that says, what is the molar concentration of a solution containing 16.0 gram CH3OH in 200 mils, that's milliliter solution? For us to be able to solve this, let's write out our parameters that we are given. We have to solve for molar concentration, which is having a symbol of C, question mark. We are given the mass of the solute, in this case mass of the solute, which is also known as weight, as mass M is 16 gram. Then we are given the volume of the solution to be 200 milliliter. If we discuss that 1 milliliter is the same thing as 1 centimeter cube, so we can also write it as 200 centimeter cube. But we need to convert the volume from centimeter cube to dm cube, because we have defined molar concentration as the amount of solute in mole dissolved in 1 dm cube of solution. That means the volume needs to be expressed in centimeter and in dm cube rather. So in that case, we divide it by 1000 and it will give us 0.2 dm cube. Now the next thing is to convert the mass to mole. We can as well solve it by using mass conc method. So let's make it two approaches. So in the first one, we need to get the molar mass, then solve for number of mole. Molar mass is going to be carbon, as we have it here. Carbon is 12 plus hydrogen. The atomic weight of hydrogen, as you can see, is 1. That is 1, but we have 4 hydrogens, 3 on this side and 1 is attached to oxygen. That is 4 plus oxygen, which is 16. So the molar mass of methanol is going to be 32 gram per mole. Since we have gotten the molar mass, we can use that to calculate the mole, as mole is defined as mass over molar mass. So in this case, we can get the value to be, the mass given is in 60 and the molar mass here is 32. So we are going to have this as the mole. Then let's actually solve for the molar concentration, and we have defined molar concentration as the amount of solute in mole divided by volume of solution in dm cube, which is expressed in dm cube. So if that be the case, we can solve for molar concentration, which is also known as molarity, as amount of solute we have calculated is 0.52 in mole over volume of solution is 0.2 in dm cube. So when we solve for this, we are going to obtain, sorry, it's not 0.52, it's a mistake there. I made a mistake there, so it's supposed to be 0.5, not 0.52. Let me clean that. So it's going to give us 2.5 mole per dm cube. And we have discussed that mole per dm cube is also known as molar. So I can also write it by saying molar concentration is equal to 2.5 molar of CH3OH. We can solve this question by using mass concentration approach. Here we solve directly, so that means we need to get the mass conc. The mass concentration formula is amount of solute, which is in gram, over volume of solution in dm cube. So that means we are going to have mass conc as our amount of solute, which is in gram, is 16 gram, over volume of solution is 0.2. So we obtain 80 gram in per dm cube of CH3OH. This is the concentration of CH3OH in terms of gram per dm cube, but we have to solve for the molar conc. So we have to remember that we should recall that molar conc is related to mass conc by the expression you can see on the screen over molar mass. So in that case, our mass conc, as we have solved it, is 80 gram per dm cube, while the molar mass is 32 gram. So that will also give us 2.5 mole per dm cube. So we have used different approaches to solve this question, and we are still arriving at the same answer. We can also use stoichiometry approach. That means we compare. Maybe we try to use that for the next question. So this is all about the first question. Now let's move to the next example. So this second problem says, what is the molality of a solution containing 20.0 gram of cane sugar, which is having the chemical symbol of C12H22O11 in 125 gram H2O? How are we going to do with this molality? Let's write the values given. Our given data, we have weight, or you can say mass of the solute. Mass of the solute, which is cane sugar, is C12H22O11. It is given as 20 gram, while the weight of solvent involved is H2O, is given as 125 gram. So to solve for molality, we should be able to use the formula that says molality or molar concentration is defined as the amount of solute expressed in mole divided by weight of solvent, which is in kilogram. So as we can see, that means we need to look for the solute value in mole. Then our weight of solvent rather is expressed as 125 gram. So we need to convert it to kilogram by dividing by 1000, and that gives us 0.125 kilogram. Now let's solve for the mole of the solute. First is to get the molar mass of the solute. The molar mass of C12H22O11 is going to be carbon is 12 times 12. We have 12 carbon and the atomic weight of carbon is 12. Plus hydrogen is 1 times 22. We have 22 hydrogen. Then oxygen is 16 and we have 11 of oxygen, and that gives us 342 gram per mole. Since we have gotten the molar mass, we can now solve for the mole, which is given as mass over molar mass. So with this, we can solve for it by writing mass of the solute is 20 gram over molar mass, which is expressed, which its value rather is given as 342 gram. So if we solve for the mole, we are going to obtain 0.0585 mole of cane sugar. Now that we have gotten the mole, we can solve for the molality by using the formula. The formula, as you can see here, says amount of solute, which is now in mole, that's 0.0585 in mole. We are working with the units over the weight of solvent is now expressed in kilogram as 0.125 kilogram. So our final answer becomes 0.468 mole per kilogram. Hence, the molality of this solution is 0.468 mole of the cane sugar over kilogram of water. So this is all about the second problem. Now let's look at the third question. The third problem says determine the mole fractions of both substances in a solution containing 36.0 gram H2O and 46.0 gram C3H5OH3, which is the chemical symbol for glycerin. Molar masses of the two substances are given, so we have to write our parameters. Given parameters data. Let's represent the two substances with symbols. Let water to be 1. That means for water we should use water, we should use 1 to represent water. Then for glycerin, which is C3H5OH bracket, we should use 2. So that means anywhere we see 1, it represents water. We see 2, which represents glycerin. But in chemistry, as we proceed in solutions, it's always expressed solute is always expressed as 2, while solvent is expressed as 1. Now, since the question says solve for mole fraction, let's analyze the problem. That is, the mole fraction of a component is defined as the number of mole of that component over total number of mole. Since we have written the expression, now means we need to solve for the number of moles of water, and that is mass over molar mass. So mass of water over molar mass of water. So that will give us the mass of water is given in the question as 36 gram, while the molar mass of water is given as 18 grams. So if we solve for it, we are going to be having 2 moles of water. Now we can also solve for the number of mole of glycerin, that is mass of glycerin over molar mass of glycerin, and that will give us the mass of glycerin given is 46 grams over the molar mass of glycerin given is 92. So we are going to obtain 0.5 mole. Now that we have gotten the number of mole, then we can solve for the total number of mole by saying total number of mole is going to be number of mole of the first component and number of mole of second component. We add them together. So for the first component, we have 2, which represent mole of water. Then we have 0.5 mole of glycerin, and that gives us 2.5 mole. So now that I've gotten the total number of mole, we can now solve for the mole fraction of water, which represents number of mole of water over total number of mole, and that will give us number of mole of water is 2 over total number of mole is 2.5. So we are going to obtain a value to be 0.2. Like I've said, it doesn't have unit since it is mole to mole calculation. It's known as mole fraction. Here we have it as mole. The 2 is having unit of mole. 2.5 is also having unit of mole, so they will cancel out. Then you can also solve for mole fraction of the second substance, which is the glycerin. That is number of mole of this of glycerin over total number of mole, and that will give us 0.5 over 2.5, and we are going to obtain our value to be 0.8. Well, 0.8, no unit, like I said, no unit for it. So in short, our answers are mole fractions of water is 0.2, while the mole fraction of glycerin is 0.8. If you check the previous video, we have already said that the mole fraction of all the components present in the solution will always be equal to 1. So for us to be able to confirm that, we can say that x1 plus x2 will give us 1. So and we will see if we add the mole fraction of the first one, which is 0.2, and we add it with 0.8, we are going to get 1. With the help of this assumption that we are seeing on the screen, if we don't want to use this method to solve for the mole fraction of x2, since we have gotten x1, we can just simply use this assumption that says x1 plus x2 will give us 1. So in that case, since we already know the value for x1 as 0.2 plus x2 and is equals to 1, so in that case we are going to be having x2 to be equals to 1 minus 0.2, and x2 will also give us 0.8. So since we've already gotten the first component, which is water, if you want to use this formula that we are seeing here, then we can also use these assumptions that says summation xi is equal to 1. That is, the addition of all the mole fractions of the component present in the whole solution will always be equal to 1. So that's about the third example. Let's move to the fourth example. Now let's look at the fourth example, which says how many equivalents of solute are contained in 1.0 liter of 2 normal solution and 1.0 liter of 0.5 normal solution. So let's look at how we are going to deal with this question. in this case, we are given the volume of the solution. The volume given is 1 liter, while the normality is given as 2 normality. So 2 normality solution means equivalent per liter. That is another unit for normality. So 1 normality, as you know, 1 normality will be 1 equivalent per liter. So now that we know the value, we are going to be using an equation that says from number of equivalents is equal to volume times normality value. So this is the equation we are going to make use of. So the N represents the number of equivalents, then V represents the volume, and N represents the normality of the solution. So in that case, number of equivalents is equal to, the volume given is 1 liter. If I'm working with liter, 1 liter times the normality value is given as 2 equivalents per liter. So with the help of the unit value, that means liter cancel liter. So we are going to be having N to be equals to 1 times 2 equivalents, and we are going to obtain 2 equivalents as our answer. So this is the number of equivalents that is present in 1 liter of 2 normality solution. So let's look at the B part of the question. The B part says that 1.0 liter of 0.5 normality solution. So we still have the same parameter. The volume is given as 1 liter as well. Then the normality value is 0.5 equivalents per liter. So our number of equivalents is equals to volume times normality of the solution. So we can solve for the number of equivalents using volume is 1 in liter as well, times normality value is 0.5 equivalents per liter. So our N becomes 0.5 equivalent. So this is all about the solution to the problem 4. Let's look at the last problem under concentrations of solution. As you can see on the screen, the last question here says calculate the number of mole of calcium hydroxide CaOH2 in 500 centimeter cube of a 5% weight per volume aqueous solution of the compound. Feel free to pause the video so as to try it. This question is actually coming from percentage unit, so we are going to deal with it together. We are given the volume of the solution. The volume of the solution, that's 500 centimeter cube. We need to solve for the molar mass of calcium hydroxide. Molar mass of CaOH2 is going to be, calcium is 40, that's the atomic weight or atomic mass of calcium, plus 2. The 2 is for both oxygen and hydrogen, and oxygen is 16 plus hydrogen is 1. Yes, so we are going to be having it as 78 gram per mole, 74 gram per mole. So after obtaining the molar mass of calcium hydroxide, the next thing is to solve for the number of mole. But before we can do that, we are given a percentage unit of 5% weight per volume. We are going to be using 2 methods to solve these questions. The first method here is to use the formula we have discussed the previous time in this section. Let's look at it together. So the first method says that since it is weight per volume, that means we are going to use formula that says percentage weight per volume is defined as the weight of the solute, which is in gram, over volume of the solution, which is in centimeter cube. Since we have this multiplied by 100, so we can say we are given the percentage weight per volume as 5%. That's 5 is equals to weight of the solute. We can say it W. Then volume of solution given is 500 multiplied by 100. So if we solve for it, the weight of the solute, which is also known as the mass of the solute, is given as 25 gram. Now that I've gotten the weight of the solute or the mass of the solute, we can now solve for the number of mole. The mole, which is N, is given as mass over molar mass. And in that case, the mass that we have solved, which is also known as the weight, is 25 gram. And we have calculated the molar mass to be 74 gram. So if we solve for this, we are going to have 0.3338, which we can approximate to be 0.340 as our value for the mole. Now we can also use another approach to solve this question. So let's interpret this. The second method, we are not using the formula. We want to interpret this. 5% weight per volume rather of calcium hydroxide simply means that since we are dealing with weight per volume, that means 5 gram of calcium hydroxide is present in 100 centimeter cube of the whole solution, or 5 gram of calcium hydroxide is present in 95% of the remaining solvent. So we can solve it by using solution approach. That is to say 5 gram of calcium hydroxide is present in 100 centimeter cube of solution, or we can say in 100 centimeter cube of solution, the amount of calcium hydroxide is 5 gram. Now that we have this, that means X gram of, that's the unknown value, that's unknown value of calcium hydroxide is going to be equals to 500 centimeter cube, which we are given from the question. 500 centimeter cube of the solution. So now we can now cross multiply by saying X times 100 is equals to 5 times 500. So if we solve for the value for X, we are going to obtain our value to be 25 gram of CaOH2. So this simply means that if in 100 centimeter cube of the solution we have 5 gram, that means in 500 centimeter cube of the solution we are going to have 25 gram. Now that I've gotten the mass, we can now use to solve for the mole by saying mole, which is N, is equals to mass over molar mass. Then we can obtain our value to be 25 gram over 74 gram per mole, and that will still give us 0.340 mole of CaOH, which is calcium hydroxide. So we have looked at the various examples, problems related to continuum of solution and its units. So in the last part of this video, I'm going to be dropping some questions for us to try and solve. You can send your answer through the comment section, so I can go through it for you and cross check to see if you are correct. Thanks so much for watching video. kindly subscribe to my YouTube channel so as to get updated anytime I upload new videos related to topics that you need to know in science. So we should be able to go through these exercises and send our solutions through the comment sections, so I can go through it for you. We have exercises 1 to 4 for you to try, so as to make you understand concentration of solutions problems very well. As you can see, try to solve them when you can.